Good morning. I'm Dr. Avina Priyadarshini, Professor of AC Department. In today's class, we shall discuss about the frequency division multiple access. So this frequency division multiple access is one of the multiple access schemes that is used for transmission of signal between the satellite and the earth station. So here, each user is allocated with number of frequency bands, and the available frequency band, the entire band will be a wideband signal, and this entire wideband is divided into number of frequency slots, and each user is allocated with the frequency slots. So here, if there are a number of users, means the available frequency is divided into a number of subcarriers, and each user is allotted with that particular subcarrier. So here all the user can transmit their signal at a time at different frequencies. So the concept is shown in this figure. So here the satellite is there, and the earth station, it has a number of earth stations are there. The communication will be established between the satellite and the earth station. So when transmitting the data along the data packets, we are using some guard bands. To the main purpose of the guard band is it is to provide for secure communication. So while transmission, there may be chances for collision of data packets. At that time, to protect the data, the guard bands are inserted. So the effect of output backoff results from FDMA operation that can be considered for overall carrier to noise ratio calculations. So the carrier to noise ratio is the overall carrier to noise ratio is given as the sum of the carrier to noise ratio in uplink and carrier to noise ratio in downlink, as well as the intermediate frequency. So therefore, for the carrier to noise ratio, the required carrier to noise ratio is should be greater than the total carrier to noise ratio. So the certain values of this carrier to noise ratio will be needed, specific in the system design, and it will be denoted by the carrier to noise ratio required. So the next is the noise to carrier ratio that is involved here. The overall carrier noise ratio must be at least greater than the required value, so that the condition is given in equation 4.19. So here we are considering the noise to carrier ratio rather than the carrier noise ratio. The actual value is equal or less than the required value. So it is indicated in this equation number 4.20. Therefore, so the right hand side of the above equation is usually dominated by the downlink ratio. So in case of FDMA, with back off is utilized to reduce the intermodulation noise to an acceptable level. So the uplink noise contribution is usually negligible in this case. So thus the above approximation signal, the above expression is approximated as noise to carrier ratio. The required noise to carrier ratio should be greater than or equal to noise to carrier ratio in downlink case. Or we can say that the carrier to noise ratio should be, the required carrier to noise ratio should be less than or equal to carrier to noise ratio in downlink. So the next, the calculation of carrier to noise ratio of FDMA system, which occupies a bandwidth of B, and the downlink power density of is denoted as EARP, and D denotes the downlink. So the carrier noise ratio for downlink is calculated as carrier noise ratio of downlink, which is equal to EARP for downlink plus G by T downlink minus losses minus K minus B. So in this equation, EARP is the EARP value which is calculated, and G by T is the gain of the transmitting antenna, and losses includes the, while downlink we have to consider different types of losses, that is antenna misalignment loss, feeder loss, absorption loss. So all these path loss, all the losses are considered. So the loss is the sum of all the losses, and K is the constant, and B is the bandwidth occupied. So in terms of the required carrier to noise ratio, this the above equation can be further modified as carrier to noise ratio required that should be less than or equal to EARP of downlink plus G by T of downlink minus losses minus K minus B. So next is the single carrier access. So with the single carrier access, number of backup is needed. So for the single carrier access, the above equation can be modified as carrier to noise ratio in required carrier to noise ratio is less than ERP in downlink plus G by T in downlink minus losses minus K minus BTR. So where BTR is the transponder bandwidth. So if the system is designed for single carrier operation, the equality sign applies and the reference condition is carrier to noise ratio required minus EARP minus G by T plus losses of downlink is should be equal to 0. So the effect of power limitation. So let the FDMA provides access for k number of carriers which shares the output power equally and each requires a bandwidth B. So the output of the each FDMA carrier is further calculated as ARPD is equal to ARP minus back of output back of minus K. So for the full transponder bandwidth, BTR cannot be shared between the carrier because of power limitation. So if alpha is the fraction of the total bandwidth actually occupied, then the value of KB is equal to alpha into BTR. So thus the values of the FDMA system power requirement for the FDMA system is analyzed. So by which the correctness ratio is calculated. Thank you.